Hey everybody, Trey here, and we've got yet another severe weather event on tap for tomorrow, Tuesday, October 26th. We had a very active night last night with multiple tornadoes, perhaps some strong, in Missouri and into southwest Illinois. There were at one time three tornado emergencies ongoing concurrently there in southeast Missouri last night. So, very active night last night, and we are looking ahead to another potentially active day tomorrow on Tuesday. We've got an enhanced risk for pretty much central Kansas all the way down through the western half of Oklahoma, down into sort of the I-20 corridor down toward Abilene. Surrounded by a slight risk that extends all the way up into Nebraska and down toward the I-10 corridor between Fort Stockton and Austin. There is a tornado threat with this system. You can see the maximum probabilities there, 5%, all the way from southwest Kansas down through western Oklahoma into far northwest Texas. There's also a damaging wind and large, potentially significant hail threat with these storms. So let's go ahead and dive in. And then we've also got actually a threat that will continue on Wednesday for the Gulf Coast. We'll try to take a look at that at the end of the video here. But for now, we're going to focus on sort of this avocado enhanced risk we have for tomorrow. Let's go take a look at our satellite. Here's our storm system from yesterday, that swirl there centered over Indiana there. That's what caused the tornado outbreak in Missouri last night. But here's our next system. You can see all the moisture associated with this system that's really starting to dig off the Pacific coast there. This big fetch of moisture is what really was aimed at Northern California and the Pacific Northwest for the last couple of days, smashing some of their rainfall records down there. Sacramento actually broke their 24-hour rainfall record with about 5.5 inches there. So very moist system here. That fetch of moisture streaming into the Great Basin region up into the northwest. That is our system for tomorrow. It's going to continue to dig pretty significantly as it moves off to the east toward the plains. And you can see here on our 500 millibar map from 12Z this morning, here's our trough there, going to continue to dig and amplify as it moves off to the east. Now, let's take a look at our surface map here. So, as we talked about with our last couple of severe weather events back on October 10th and October 12th here in Oklahoma, when we get back-to-back systems like this, often our worry is the moisture going to be scoured down into the Gulf? Usually, oftentimes, we get these cold fronts to really just wipe all that moisture away. And it usually takes a lot to get all that moisture back in. So these concurrent systems, the second system sometimes has trouble getting that moisture back in, which is somewhat what we saw last with our last couple of setups there. The October 12th setup, the Clinton, Oklahoma tornadoes after dark. Areas farther north didn't quite see as rapid of moisture return as areas farther south did into Oklahoma. That's not going to be the case here, I don't think, though. You can see here on our surface map, our 70s dew points are still well in place here up through central Texas toward the Waco, Austin areas, really over to Del Rio and areas south of that. We've got ample surface moisture here, dew points approaching 80 down here as you go down toward Brownsville, Corpus Christi. So very moist air mass at the surface here. So we did not get wiped out. Dew points in Oklahoma have definitely decreased a little bit. We were in the mid-60s yesterday here in eastern Oklahoma. They've dipped into the low to mid-50s here, but you can still see we've got a 64 dew point there in southeast Oklahoma. Whether or not that is accurate, because we don't quite see that high of dew points around it. But still, we've got dew points approaching 60 here near the Red River. So it's not going to take a whole lot to get this moisture back into the central and southern plains for tomorrow. And, as we've said, pretty much with every setup we cover on here, as this trough traverses the Rockies, we're going to get lee cyclogenesis here to the east of the Rockies, get that southerly flow to ramp up and increase the moisture return up into Oklahoma, Kansas, even Nebraska here for tomorrow. Well, let's take a look at the quality of that moisture. And let's start down in our source region here, Corpus Christi. And you'll notice here from our video we did covering yesterday's setup in Missouri a couple days ago, we saw a pretty moist profile all the way up through the column here at Corpus Christi and Brownsville. Not quite the case today. We've seen a little bit more dry air start to impinge on the profile here. We still have a decent moist layer here up to about 850 millibars. That is definitely decent, although we saw definitely a much more moist profile here throughout the column here a couple days ago. Same story here at Brownsville. A little bit drier air aloft here, a little bit shallower of a moist layer. So that is a concern we may have if you recall on October 10th, if you were chasing out there in southwest Oklahoma that day. The storms went pretty HP pretty quickly. There was quite a bit of dry air aloft, which may have had something to do with that. So that'll have to be watched here. If we get some more dry air aloft, drier air entrainment is not favorable for sustained supercell maintenance. So we'll have to keep that in mind. We do see some evidence of a residual EML even down here as far south as Brownsville. This layer of kind of steep lapse rates here between 700 and 850 millibars. It's kind of the same thing at Corpus Christi there. If we go up to Dallas, we kind of see that same sort of layer there. And we'll go back toward the Texas Panhandle. Not quite as steep lapse rates here, so not as much of an elevated mixed layer present out here to be advected eastward. Tomorrow we'll go all the way back to Albuquerque, and you can see we're really not dealing with a lot of warm, dry air and steep lapse rates aloft. So that could be a sign that we're going to see a little bit less of an EML than what we saw with our past couple of events out here, which may help storms get going a little bit earlier than the October 10th and 12th setups the October 12th setup in particular got going right at dark, and the tornadoes occurred after dark. That may not be the case here. We're not going to have as strong of an EML here. We still should have some residual EML here. This little bit of layer here at Dallas. We'll go to Lamont. Still kind of see those steep lapse rates here a little bit aloft. So there will be some sort of capping inversion that will help negate storm development for the afternoon hours, but when that forcing arrives, it shouldn't be too hard to breach that remaining elevated mixed layer there. So let's get into the models here real quick. We're going to take a look at the NAM and the GFS here. We'll start off with the NAM, take a look at how it's initialized here. This is 500 millibars. Both of these will be the 12Z run from this morning. Here's a 500 millibar map from 12Z. You can see it's initialized very well. We've got our trough out here just off the California coast there, some ridging over the northern and central plains here, and our system from yesterday here moving off into the Great Lakes region. Much of the same what we see here. So the NAM is initialized pretty well here. GFS, much of the same. It's initialized very well. There's our system there from yesterday, ridging over the plains. That very potent trough here about to come on shore here in California. So here's the NAM. We'll go forward in time. You can see it continues to dig, continues to amplify a little bit, takes on a pretty negative tilt there as it moves off to the east. And you'll notice this little sort of feature down here in Mexico moving northward, and that is actually going to be the remnants of Hurricane Rick. Hurricane Rick made landfall this morning on the southern coast of Mexico as I believe a strong category 1 to category 2 hurricane. It's now weakened rapidly, and the remnants of that will continue to move north and will actually be more of a player for Wednesday's severe weather event in the southeast. You can see it kind of merges with the main trough. You kind of have these two lobes. This is the remnants of Rick, and then our main lobe kind of back here across the plains that will continue to move off to the east for Wednesday's event. But won't be much of a player on Tuesday. Just wanted to point that out. But here's our trough on the NAM. You can see it takes on an increasingly negative tilt, as we said. And you'll notice the flow aloft here is quite meridional. And by meridional, we mean more north-south. Zonal would be east-west, meridional north-south. The flow aloft here is quite meridional. And usually that's not super favorable for discrete storms, but we'll take a look at the shear vectors as they relate to the initiating boundary here in a second. GFS is going to show us much of the same. That trough will take on an increasingly negative tilt. There's the remnants of Hurricane Rick down there. And this is 0Z tomorrow, so 7 p.m. Central Daylight Time tomorrow. You can see much of the same. So the NAM and the GFS both depicting pretty much the same sort of setup here for tomorrow, so pretty good agreement there. Let's go down to 850 millibars here. This is where we look at our low-level jet. And we'll go back here to the start. You can see we've got a little bit of a low-level jet here out in the plains this morning. We'll continue on throughout the day today, and then we'll get, as that trough really starts to dig, we'll get this broad sort of swath of stronger winds here after dark tonight, and that will kind of linger through the day tomorrow, especially as we get continued low-level cyclogenesis here to the lee of the Rockies. As that mid to upper level trough traverses the Rockies, we'll get continued surface cyclogenesis here. So that low-level jet will stay fairly strong here throughout the day tomorrow, which should help really ramp wind profiles up as far as supercell wind profiles go. You can see broad swath of 40, 50, 60 knots here, extending all the way from the I-10 corridor down here into West Texas, all the way up into Canada here. So big fetch of a low-level jet here that will only increase after dark here. Just after dark, we see over Kansas and Oklahoma upwards of 50, 60 knots here. So low-level jet will be in place throughout the day tomorrow. GFS showing pretty much the same scenario here. We get continued cyclogenesis there throughout the afternoon tomorrow here over eastern Colorado. Big, broad fetch of strong winds here, just about a kilometer or so off the ground. And you'll notice the NAM is a little bit stronger, at least in magnitude here with the low-level jet, but overall, both of these depictions are going to be fairly favorable for supercells throughout the day, throughout the afternoon and evening tomorrow. Then the GFS does ramp up a little bit after dark, although not too much, actually. Surprisingly, we don't get that traditional big ramp up in the low-level jet after dark, but definitely will remain adequate to keep any storms going here after dark. Depending on storm mode, of course, the hazards are going to be different with a squall line versus discrete supercells, but we'll take a look at that in a second. Let's go down to the surface here and take a look at what both of these are showing. Surface pattern, again, we should see surface cyclogenesis start to ramp up throughout the afternoon tomorrow as that sort of speed max traverses the Rockies. And there you see, by about 18Z, we really get consolidation of that surface low up in northeast Colorado there, kind of stretching all the way down into northeast New Mexico, up into Wyoming there. So broad fetch of southeasterlies here at the surface, going to really start pumping that moisture northward by afternoon tomorrow. And so given that the 70s dew points are still just hanging out here in central Texas, I don't think that moisture is going to take a lot to move northward rapidly. And once that surface low really starts to get to consolidate there, that moisture really should start to pull northward. So there's our surface low on the Kansas-Colorado border there by 0Z, 7 p.m. tomorrow, Central Daylight Time. You can see strong southeasterly winds here at the surface, what we want to see for tornadic supercells, in most cases, especially on the plains. And then we'll go to the GFS here. Similar sort of evolution. We get really that consolidation right about 18Z, northeast Colorado there, and by 0Z. Now, this is a little bit of a difference here. The main surface low is a little bit more progressive here on the GFS. It's all the way up into southwest Nebraska, northwest Kansas there by 0Z, while here on the NAM it's hanging back a little bit on the Kansas-Colorado border. So a little bit of a difference there. How much difference that makes is not really going to be a whole lot, I don't think. Just going to be the position of the dry line / cold front here. The dry line may be a little bit farther east here on the GFS than it is on the NAM. NAM looks to be a little bit farther back here into the Texas Panhandle, more in toward the Texas-Oklahoma border here. And we'll take a look at the moisture actually now to really see where that dry line sets up here. And so this is the NAM. Dew points, you see, start to really surge northward by afternoon tomorrow. They get all the way up into northeast Kansas, those 60s dew points, which are the blue colors here, by 7 p.m. tomorrow. Even by 21Z, they're still hanging back a little bit there, but still up into southwest Kansas. But you can see a very well-defined dry line there, and we'll zoom in actually. Actually, let's take a look at the GFS first, see what it does. And the GFS actually here is a little bit different. You can see little bit interesting that it pulls those 60s dew points well east. So the um, almost a more sort of, this is very interesting, very odd. I don't know if I really believe this. Not sure why those 60s dew points wouldn't really back up to that wind shift line as we saw on the NAM. So that'll be something to watch. I'm not sure I believe that these 60s dew points will be well removed from the actual dry line. I think we will get 60s right up there along that wind shift line that is sort of the dry line there. But let's zoom in, take a look, take a closer look here. We'll go to the Southern Plains sector. You can see very tight dry line. We'll have to see how that moisture progresses because that will modulate how far north the severe threat is going to go. If the 60s dew points move up into northwest Kansas faster, then we should get a better chance for severe storms earlier than what this model is showing. But I think definitely down here into northwest Texas, the eastern Panhandle, into western Oklahoma, storms should initiate fairly rapidly here by mid to late afternoon, given we saw kind of a lack of elevated mixed layer there in our soundings. So we shouldn't have too much of an elevated mixed layer to deal with. So once that forcing arrives, we'll go to 500 millibars real quickly here. Yeah, once this sort of speed max arrives, once the forcing arrives, we should get pretty rapid storm development here. I would say this is going to be at 4 p.m. Central Daylight Time, so I think about 4 p.m. Any short waves here to note, and I think we could easily see these little kinks in the flow here. Could easily set storms in motion here, even into Kansas, north of the best moisture here, by about 4 p.m. tomorrow. So shouldn't be a question of getting storms to go before dark this time, given we have a pretty strong dryline circulation here on the NAM, and that pretty strong forcing here moving in, coincident with that, by about mid-afternoon tomorrow. So, and then the GFS here, again, I'm not quite inclined to believe this, that the 60s dew points will be much farther off to the east. As we said, the GFS is showing a little bit farther east dryline position, at least initially, than what the NAM is showing. It's a little bit farther west into almost the central Texas Panhandle. So something we'll have to watch tomorrow for sure, where exactly that moisture sets up. But again, I think these 60s dew points will stream a little bit farther east. A little bit farther west fairly easily. I don't quite believe this depiction here from the GFS. So this NAM depiction looks pretty good. Again, going to have to watch the surface maps tomorrow to see what happens. But all in all, it looks like we've got a tornado setup in place, at least a supercell setup in place. Let's take a look at some soundings here from both models. I'm going to take one up here. This is going to be 21Z, so we'll take one up here on the dry line up into southwest Kansas. How about the eastern Texas Panhandle here? And then we'll take one kind of on this little bulge here in the 60s, sort of by the Vernon area, and then we'll take one down here toward the Texas South Plains there. So this is up in Kansas early on. NAM is showing a really stout cap in place. Now it's only showing about 70 degrees here at the surface, and the NAM has been doing a really horrible job at depicting the surface pattern lately, especially the surface temperatures. And this has been a bias with the NAM for a long time. It's often a little bit too cool with the surface temperatures, and we saw that especially on the October 12th setup, the Clinton, Oklahoma after dark tornadoes, especially down in southwest Oklahoma where we had that southern supercell near Snyder produce multiple strong tornadoes, it appears. The NAM completely underdid the surface temperatures down there. We saw temps rise easily into the 80s down there when the NAM was only showing even upper 60s to low 70s. So something to watch tomorrow, how warm we do get, because this is a pretty stout cap, and I wouldn't expect that to be the case given what we saw on our soundings. Not a whole lot of residual EML to speak of out here. Maybe a little bit of a layer here at Amarillo, but Albuquerque, not a whole lot there. And not a whole lot there at El Paso either. So I'm not quite inclined to believe that, especially if we do get warmer temperatures than what the NAM is showing. But we'll go down into the eastern Texas Panhandle. You can see here the curvature in the hodograph already here by 21Z. So is favorable. Supercell wind profile here. There is a little bit of a weakness here in the mid-levels, and we can discuss the veer back veer signatures all we want. If you've got an initial storm mode that is favorable for discrete storms, this veer back veer doesn't really have a whole lot of influence, it seems, on the storm evolution and storm longevity. But again here, we're really cool. 68 degrees here at the surface in the eastern panhandle. Now this is down into northwest Texas here. We're at 84 degrees here, so that may be a little bit more realistic. But still, this very stout cap is in place, and I'm not quite sure why the NAM is showing this. Same thing down here into central Texas, showing 72 degrees. I just don't believe those surface temperatures at all here on the NAM. I think we're easily going to get, with sunshine, I think we're going to easily get up into the at least the upper 70s, probably into the low 80s, I would assume. But let's go to 0Z, see if that cap does erode a little bit more. Here's southwest Kansas. We'll again go to the eastern panhandle, northwest Texas, and we'll go into central Texas as well. So southwest Kansas, you can still see that cap is in place, and we're still showing 63 degrees here at the surface, which I don't buy at all. So I'm inclined to think that this is not going to be the case. We're going to have storm development pretty easily by the mid to late afternoon hours. Wind profiles here, once again, pretty decent curvature here in the low levels, over 250 meters squared per second squared. We do have that little bit of weakness, but again, if we can get discrete storms, which we'll take a look at here in a second, I don't think this is going to be too much of an issue. Might be a little bit more grungy, but I don't think that will be too much of an issue if we do have discrete storms. Now here in the eastern panhandle, this is going to be a little bit more realistic, I think. Now surface temperatures may be a little bit too cool still, only 68 degrees here at the surface, but much less of an inversion here in the eastern panhandle. And you can see large looping hodographs here in the low levels would be favorable for tornadic supercells here. So very interesting here. At least in a numbers perspective, surface-based surface-based convective inhibition is much less here across the eastern panhandle. Same thing here in northwest Texas. There's a little bit more of an inversion there, a little bit warmer temperatures here in the mid-levels. Not quite sure that's the case, but that is not that much cap at all. So if we do get even a little bit warmer than that, that'll be easy to erode. Again, down here, even large looping hodographs. And then down into central Texas, where the strongest flow aloft is a little bit displaced to the north here. Still, we have a severe storm-looking hodograph, even potential for tornadic supercells here. But more so maybe a hail threat, but a little bit more of an inversion down there. And again, going to have to take a look at the surface temperatures throughout the afternoon tomorrow, because I think they're going to get warmer than this. GFS, real quick. Again, I don't believe this surface moisture pattern here, but we'll just take a few soundings. This is going to be at 0Z, and this will be a little bit farther off to the east. Again, you can see large looping hodographs in the low levels, a little bit, again, warm temperatures aloft. And perhaps that is a little bit of what we were seeing out here at Albuquerque, kind of just overall warmer temperatures, not necessarily steeper lapse rates, but just warmer temperatures aloft. So that may be a little bit of a hindrance in hindsight here, looking back at these. As this warm air aloft will advect to the east, that may be playing a role here in what the NAM is showing. But again, I think if the temperatures can get into the upper 70s to low 80s, I don't think that will be too much of an issue tomorrow, especially as that low-level jet ramps up a little bit near sunset. But again, large looping hodographs here, almost 400 meters squared per second squared here up in Kansas, South Kansas. Again, looping, a little bit of a kink there in the hodograph is a little bit of a concern, but storm mode is going to be, I think, the main modulator there. Now down into sort of northern Oklahoma here, a little bit less of an issue with the warm temperatures aloft. Still there, still a concern, but that is definitely a little bit more breakable there. Down into Texas, kind of the same thing there. So let's look at storm mode here. We'll look at the NAM here. So pretty much a north-south oriented dry line here. And then let's take a look at our bulk shear vectors. And so here that you can see that cape axis and on the NAM here, a little bit very capped here. But you can see we've got definitely a significant component of these shear vectors, the storm motion vectors here, that are, actually let me go to Moo Cape, most unstable Cape here. That'll show the bulk wind difference here, or bulk shear here. So here's our dry line, and then you can see a pretty decent component of that shear vector is normal or perpendicular to that dry line. So we should have at least some window for discrete storms, especially with northern extent. A little bit more difficult, I think, down here where the dry line sort of arcs back toward the southwest. Perhaps maybe a little bit more messy mode down here. But I think definitely a window for discrete storms here if we can work out these thermodynamic sort of deficiencies in some of these soundings, which we'll have to watch. If we get that sort of warm air to advect eastward enough, that may sort of hinder surface-based storm development to some degree. Maybe that could lead to more of a multi-cell cluster mode that would line out fairly quickly. This is at 3Z after dark, and then we see that the main forcing sort of arrives, and that dry line really starts to push off to the east, and that's when I think we'll get pretty rapid squall line development up here. But I do think there is a window for discrete storms up here. If they can be surface-based, I do think they will have a threat for large hail, damaging winds, and tornadoes, and then more of a damaging wind threat as that sort of dry line / cold front moves off to the east there. Let's take a quick look at Wednesday here, just real quick here. So you can see this is the 500 millibar map on the NAM. We'll just look at the NAM here for simplicity's sake. But there's the kind of the remnants of Hurricane Rick there, and there's our trough that's going to modulate our severe weather event for tomorrow. It's going to really start to dig and amplify and kind of close off here. Broad fetch of strong winds here in the exit region of that trough. Nice defluence here in the exit region here. I would expect, if we see, let's take a look at our warm sector here. So I would expect, and one thing to note, that warm sector really gets pinched with northern extent here into the overnight hours into Wednesday morning. But given that we do have an unstable sort of moist warm sector here, I do expect storms to continue overnight and into the morning here. So we may have a squall line. Just given the degree of forcing and the instability within the warm sector here, we should have storms continue on into Wednesday morning and afternoon. And really not much of a warm sector here on the NAM. It gets really pinched. If we can get storms out ahead of this, the flow should be very strong. So if we can get any sort of discrete supercell development out ahead of the main squall line, it probably will be ongoing here throughout the afternoon. Yeah, the profile will be definitely favorable for tornadoes, perhaps some even strong. So we'll have to watch that. You might notice here the instability is quite weak here, just from what we've seen with typical sort of severe weather events. We'd like to see a lot more instability than this, but you'll notice 0 to 3 kilometer instability is fairly large here, and the instability is kind of confined here into the low level. So these will be very low top storms if they can form out ahead of the line. But regardless of storm mode here, discrete storms out ahead or in the squall line, there will probably be a few tornadoes given this really strong curvature in the hodograph here in the low level. So we'll have to watch that for Wednesday. Could be a couple storms out here in far east Texas, southern Louisiana, but that warm sector really does get pinched, so there's not going to be a whole lot of room for discrete supercell development out here ahead of that squall line that will probably continue on throughout the day on Wednesday. All right, just for giggles, let's take a look at some of the convective allowing models for tomorrow, Tuesday here. This is the HRRR, and again, don't take these literally. Take these with a grain of salt. These cams are not that good this far out. So this is the 12Z HRRR. You can see as we go on throughout the day here, this is Tuesday, lagging a little bit here. There we go. So by 21Z, 22Z, we're not seeing much in the way of development down here. And then finally by 1Z, so the HRRR is definitely a little bit later with development here. We start to get initiation here in southwest Kansas, and then down here into west Texas. And then we really get rapid storm development here by Tuesday. Kind of a messier mode here, perhaps some semi-discrete storms down here, but a little bit messy mode here. Kind of a void here along that dry line in the eastern Panhandle, western Oklahoma, which is a little surprising given the degree of forcing. Then we do get storms to kind of build down along that dry line later on, but her looking overall a little bit messier, perhaps some more semi-discrete elements up here into Kansas and northern Oklahoma. But I think that's fairly, this is what we'd expect to see. A little bit less flow aloft down here, a little bit less shear, perhaps a little bit stronger cap down here may favor a little bit more of a multi-cell mode down here. But we'll have to watch that throughout the day. And then we get kind of this sort of squall line to develop and move on to the east overnight. This is the WRF ARW here. And we'll go forward into Tuesday. And you can see not much before 0Z. Maybe some initiation down here into West Texas, but we're at 0Z and don't see much here on the radar. And by about 3Z, we get storm development here up in southwest Kansas and down here into Texas. Again, kind of a void here on the dry line, which is very surprising. We'll have to watch that and see if that's the case. A little bit stronger, perhaps convective inhibition in this region. And then finally, later on, we get kind of a broken sort of squall line to develop and move off to the east. Kind of the same as what we saw on the HER. Let's take a look at the 3-kilometer NAM real quick. And then we'll look at the NSSL WRF and then wrap this up. 3-kilometer NAM. So 3-kilometer NAM showing initiation about 0Z here. Now, it's showing it pretty much solely in the eastern Panhandle along that dry line, which is a lot different than what we saw. Perhaps some supercellular elements in here as well. Kind of a broken line here that kind of fills in throughout the evening as it moves off into Oklahoma and South Kansas. So interesting differences here among the cams. Well, finally, we'll go to the NSSL WRF just to see what it shows. And by 0Z, not showing much, maybe initiation down there in northwest Texas. Not a whole lot. This is interesting. Could be a product of that little bit of warmer air aloft. I wouldn't necessarily call that an elevated mix layer, because it's just kind of a layer of warm air aloft. So that'll be interesting to watch. If temperatures can warm up into the low, even mid 80s, I don't think that will be too much of an issue. But that is kind of concern. If temperatures do not get quite as warm as expected, this warm air may hinder sustained supercell development, at least surface-based supercell development along that dry line. So something we'll watch going into tomorrow. But if we can get surface-based storms, the wind profiles do dictate that they could produce large hail, damaging winds, and a few tornadoes, so we'll have to keep that in mind. Once again, we've got an enhanced risk out here for tomorrow, Tuesday. So if you live in these areas, from all the way from even southern Nebraska down through west Texas, keep an eye on the weather tomorrow. Could be a potent severe weather day, whether it is a squall line or discrete supercells. Going to have to keep an eye on that if you live in these areas. So that's all I've got for now. Thanks for watching, and we will see you in the next video.